Assalamu alaikum. Welcome to the last part of the tutorial for Logisim beginners. And now we're going to talk about memory components, which are really important, especially when you are designing a CPU. So this is going to be like the brain of your CPU. This is where you're going to store the instructions. This is where you will have data going from one place to another in your circuits and CPU, basically. Now, memory components, the basic components of memory is flip-flops. And as you know, flip-flops basically need a clock. As you see here, you have a triangle, so they work based on a clock signal. For instance, when you have a D flip-flop and the input you insert it to be 1, nothing will change to the output until you press on the clock or you send the clock signal. After one pulse, it will change the state of the flip-flop, and this will reflect on the outputs. Now, we will see what we mean by clock signal more when we work on Logisim, and also you have to choose what kind of flip-flop you have. So is it a rising edge? So rising edge is basically when the clock chain goes from 0 to 1. So as you see here, it's drawn for you the pulse of the clock. So this is 0, low level, and this is now like the rising edge. And then we have the 1 level, the high level, and then we have a falling edge. And it matters to know like your flip-flop basically changes state at which like position in the clock pulse. And we will see how we can decide that. Now, as I said, flip-flops are the basic components of memory. And there are two types of memory. So we have actually more than two types, but we can store data in a register. And this is one aspect of your project. You will make a register where you will have a source register and destination registers. And basically you will send data from, sometimes you'll read data from that register, sometimes you will send data and store it in that register. And registers are made of flip-flops. So it's basically, because you know, a flip-flop, a single flip-flop, you can only have a single bit. So this is either 1 or 0. If you want to have data of more than 1 bit, so 2 bit, 3 bits, whatever, you need the number, so the number of bits will be the number of flip-flops. So if you need 2-bit data, you need 2 flip-flops. Now in Logisim, you do have a register that's made ready, which is actually a combination of flip-flops, and you have to decide in the properties the data number of bits and the data bits. In this example, it's a 4-bit, and we can see that the D pin, which is the data input, we have 1, which is a 4-bit number. And when the enable pin, so we have this enable pin, it's called write enable. If this is 0, so here we can see in the truth table, if this is 0, no matter what input change you have, even if the clock, it's working, no change will happen. This is why we have the don't care here, because it's like disabled, this flip-flop. And this is a very useful property, especially if you have multiple registers. So this is actually a register, right? A 4-bit register. And we can call this R0. And if you have multiple registers and you want to send data to a certain register, then that is the one that should be enabled. So that's the one where it has to be 1 here. And if there's no clock, still nothing will change. But once we have this positive or rising edge, since our register type is rising edge, you will have the change, which is basically your input goes to the outputs. You can also reset your register by pressing this button. So you have the R for resets. In this video, we'll also talk about counters. So counters is also made of flip-flop, and a counter basically all it does is count from like a number to a number with a certain pattern. You can design any series you want. You can do a simple counter that counts from 0 to until here, which is 15. So because you have 4 bits, so 2 to the power of 4, it counts numbers from 0 to 15. And this is using JK flip-flops. And it's called a ripple up counter. I really advise you to try to implement the circuit to understand more how this flip-flops work, and this will help you better implement the memory with the counter. Now, the reason why we talk about counters is because they're needed, especially when we are working with the ROM memory. So the other type of memory, so there's the registers. We can store data in ROM or RAM. They're similar in Logisim. So as you know, read-only memory is the ROM, and this is suitable especially if you want to store instructions of a computer. So you know, instructions are not supposed to be like modified during the CPU process. So you can store your instructions here, and I'll show you that as well. And to navigate from one instruction to another, we need to count. We need the counter that goes from address 0 to address 1, 2, 3, 4, 5, 6. You see here, this is the index of the first memory location in that line. So let's open Logisim. So when we're talking about memory components, we have to go to the folder memory. We can find all the components here: D flip-flop, JK flip-flops, register. Let's start with the register. So I chose to have a register. I want it to be, for example, I'm gonna choose 4 bits. Could be 7 bits, 5 bits, whatever. And we can keep the trigger as rising edge. So I'll make this for all components in my circuit. Let me zoom in. So as we said here, D is the data. Let's put an input here. Our data has to match the number of bits of the register, so I can call this input. Let's make 2 registers. Just copy paste. And I'll connect this input to both. I'll call this R0, and this is R1. Now notice here we have the triangle, which means this is where we have to put the clock, and you will find the clock in wiring. And I prefer, especially if you have multiple registers, to put one clock here and then use tunnels. So we don't have so many unnecessarily, like so many wires. I could have done that for the input as well. So all my registers need to be operating on the same clock. And we don't need the output. I think it will show the value here anyways. So let's try, and for the enable pin, let's put it to be 0 for now. It should be an input. I'll put a number, for example, 1. Okay. Now for the clock, you can test it by pressing. So this is the first click. So now, second click. We see nothing is happening. Like the value is 0, 0 for both. Although my input is 2. So as we said that the enable pin, I don't know if it's written here. Yes. I think if you put your mouse here, even if you forget, it tells you when 0 clock triggers are ineffective. So let's make R01 and see what happens. So R0 stores the value 2, which is coming from this input. Although both registers are connected to this input, only R0 is changed to 2 and the clock is connected to both as well, just because it's enabled. And this is how we can choose where our data goes, to which register. We can make them to both if we wanted so, or usually you would send it to one of them. And here the output, if you want to use this somewhere else, or if you are reading from the register, you need to connect here from the outputs to get the value too. Now, of course, in the project, like the enable pin and most of the components, even the inputs, all of these should be an automated process. So this will be data read from somewhere else. This enable pins should be changed based on something that you have in the circuit automatically, and so on. So this is for the registers. Let's now see how the memory works. By the way, you can make, if you have a big circuit, you can make it all here. Oops. Or if you want to have separate circuits for each, you can put add circuit, for example, and we can put the circuit as registers, for instance. Double click here and copy all of this to registers. And then once my register circuit is done, what I can do is in the main, you just click on this and you will have a block here showing you the register circuits and what inputs it's expecting. So this is probably the 2 enable pins, and here it's the data. And this way you can have like the main circuit, like with the different blocks or registers, ALU, or you can have everything in the same circuit. That's up to you as a designer. Anyways, so I want to show you the memory, so the ROM. So I'll go to memory and you can find it here. Now by default, the address bit width is 8. So 2 to the power 8 is 256 memory locations or addresses. And each address is 8-bit. So data bit width is 8-bit. And we can see here, so in this address location, which is address 0 or location 0, we have 00. So this is actually, this 0 is a hexa number. So this is one hex number which has 4 bits, and this is another hex number which has 4 bits. So in total they are 8. And to edit the contents, so I can imagine you putting all the instructions here. So your instructions will be will have a certain length in terms of bits, and you should design your ROM to support that length. So the numbers here are just an example, but you have to design or make your ROM suitable for your instruction length. So you can click to edit here in the contents. And you will see that you have 16 columns and 16 rows. So you have from 0 until F, so which is 15. So you have 16 columns and 16 rows. So 16 times 16 is indeed 256 memory locations. So for example, which is really big, by the way. So here I will put for my first instruction maybe is 1A, and then the other one is, so you just have to type and then you can go to the next one and put 25. I think with space you can go from one to another. So all of these are like, this is location 0, 1, 2, 3 until 9. And then here you have 10, 11, 12, and so on. So I put 2 instructions. One is 1A and the other is 2.5. So this instruction is based on so 1A will be, let me show you. Can put an output here to see what is that in in binary. What is the instruction in binary? This should be 8-bit. Okay, so I want to see the first address location and the second and the third. And to navigate through these addresses, I need a counter that goes from 0, 1, 2, 3, 4, 5 until whatever. It depends on how many addresses you have or how many instructions you'll have. So from here, this is where it's expecting the address. So if you have a number 5 coming here, it will go to location 5, which is this one. If it have 2, it will go to location 2, and so on. So we need to basically connect our counter here. So let's connect a counter. Now this is the counter in Logisim. It looks a bit sophisticated. Let me move things first. Okay, and then let's put our counter. I'll connect it directly to this. So my counter has the value 0, and this is what the ROM is already getting. So it gets 0, so it's here. The ROM is reading this location, and this is why it's displaying 1. So you see the 4 bits here are 1, and the other 4 bits here are A. So here you have number 10, which is in hex is 10 is A. Now, if I want to navigate to the next and next and next, I need to make this counter work correctly. Now, it looks a bit sophisticated, actually, because it has 2 modes. So the first mode is to operate as a counter. Now, if you wanted to count up, so you have to connect to M3, and it should be 1. So let's connect it 1 to here. And we also need a clock. So let me put the clock as well. That's from wiring. I'll just put it directly. Okay. Now, if I make it up, so if it's down, it will be counting down. Sorry, if it's 0, it will be counting down. And if it's 1, it will be counting up. So now when I press the clock, you see that it moved to the next location. This is 25 or 25. So here I have 2, and here I have number 5, and so on. So as the clock goes, it will keep going to the next address location. So this counter is easy to use, really. It's already ready. So that's what you need. Now, suppose that you don't want it to count just up, like going from 0, 1, 2, 3, 4, 5, 6. You want to go to a certain address location. I want, for example, to 18 or 19 or 20, like a certain one. So here you will use, instead of the up and or down like modes, you will use the load mode. And this load basically will load the data from here. So the address, you will get it from here. The address location, you will insert it from here. And this is especially used if you have instructions that are using branching and you want to access a certain like address location. I hope it's clear. Of course, all of this, like these operations should be automated, as I keep saying. I'm just here showing you mainly the components, how they work. If you have questions or you run into technical issues, please email me or come to the office hours. Thank you.